Hello, I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Todd Tuthill, Vice President, Aerospace and Defense Industry, Siemens. On today's episode, we'll discuss why companies should embrace AI now and not wait. We hope you enjoy this episode. Todd, welcome to the podcast.
Grayson, wow, great to be here. Talking about my favorite topic, aerospace, and maybe a little digital transformation thrown in just for fun, huh? Can't wait to do it. Been looking forward to it.
Aerospace is awesome. It makes the world go round. We can go to different continents, all sorts of things.
Is there anything cooler than building big metal things that fly and being able to build them and fly inside them? It's been my career, and I just love it. I love watching them. I love flying in them. I love all things about aerospace. Absolutely.
It'd be really cool if you can make an AI pilot that can be like a Blue Angel. Now, that would be really cool.
Anything's possible, right? But what would be the fun of that, right?
It'd be fun to accomplish it.
It would be fun to accomplish it, you're right. But I think there's a good reason to have real people flying Blue Angels on the part of the Navy. So I think it'll be a while before we see that. There'll be lots of things we'll see AI do, I think, before we see AI flying in a Blue Angels jet.
AI is going to impact a lot of things, a lot of industries. Aerospace is going to have a big impact. How are you preparing for the potential impact that AI is going to have on aerospace?
We're using large language models and things like that, but we're doing so much more with AI. We've been in AI for more than 10 years at Siemens. And from our perspective, AI, we're a technology company. So our goal is not to sell AI. Our goal is to use AI to make all of the products we sell better. That's really been our high-level approach in our strategy with AI. That there's so many things AI can do in so many industries, and certainly within aerospace and with kind of product design industries in general, AI can make that process more efficient, can make it better, and that's a high-level answer. And I'll stop there because I think we're probably going to unpack several more of those things later in the podcast.
How is Siemens using AI to make products better? Is it on a per product basis? Is it an overall corporate strategy? How are we using it to make products better?
We're doing it in several ways. Again, if you think about the different aspects of AI, we talked about large language models and ChatGPT, but let's talk about several other things that we can do with AI right now today. We can talk about topology optimization. We can talk about optimization of simulations. We can talk about generative design, because people think of generative design sometimes like Skynet. And okay, we're going to enter a prompt and an airplane's going to pop out. And we're not quite there yet. But there are several things we can do with respect to generative design and designing aspects of a product. It might be an electrical wiring design. It might be a mechanical part, or it might be support materials for one of those things. So certainly that's an aspect of things, or maybe an expert system. And we're applying each of those things to several of our products. And maybe some of the less sexy things, one of the really important things I think we're doing with products is predictive algorithms to understand what's the next task you want to do with one of our key tools. Anyone would know if you used key sophisticated design tools, sometimes the hard part is knowing what to do next. And AI can really, we've embedded that kind of AI knowledge into a number of our key tools to say, here's the way a subject matter expert might work. And then it can also watch you work and start to predict the next tool based on the tool flow that you're in. These assistive technologies. And I'd like to say that while we do generative things, and I think we're just at the beginning of AI, I really see a big part of what we're doing with AI right now is assistive. It's taking what you do every day and making what you do every day easier and more efficient.
From the aerospace angle, when you're working on an aircraft, does that impact the FAA certification that AI was used as part of that? Does the flags go up? Hey, wait a second. Anything there?
Any tool that you use in the certification of an aircraft is subject to FAA approval. But we're not to the point yet where we're completely doing the end-to-end design and validation of a product completely with AI. In other words, we're not pushing a button and the airplane wing falls out. So I think from an FAA perspective, I don't see any difference between AI And what we do with AI right now, or any great difference there with respect to the FAA, than I would with a simulation tool or another design. It's just another tool in the toolbox. And to use that tool, there are things that are required on the part of the FAA to understand the validity of what that tool produces. And at the end of the day, the output of that tool has to be inspected and understood by a real human engineer before it's allowed to pass on and be a part of the type cert for an aircraft or the things that the FAA might require.
Staying on the tool and toolbox angle, what does AI enable you to unlock as it's for the development of aircraft today that was not possible before the development of AI when you started using it 10 years ago?
Wow. We don't have enough time on your podcasting to go through all of those things, but we can talk, and I mentioned a few of them, but let's talk about a few things AI can do right now today. Okay, we have the ability today, and it's one of the things, quite frankly, that I've wanted to do for a while in engineering. If you think about, the process of creating things, what engineers do. And I go back to my time as director of engineering in previous companies, and I would watch what my engineers would do all day. And I think about the time I was in school, when engineers went to school, and we had these grand ideas in our mind about what engineering would be like. I'm going to come out of school and I'm going to think these big thoughts and I'm going to do all these fantastic, innovative things. And the reality I found, and most engineers find, is that engineers spend a lot of their time doing really mundane things. They spend their time searching for information, preparing reports, putting things together. And one of the key things AI is doing now that it couldn't do maybe 3 or 4 years ago is it's doing a lot of this mundane work. So imagine the time it takes to assemble a bunch of information from a bunch of testing that you've done and write a test report. AI can do that for you today. Another use case that we have customers using right now with our tools, I can take an architecture from an architecture tool, and I can take that fundamental architecture and generatively create a design for a wiring system from that. And all the tedious aspects of point-to-point wiring, we can do a lot of that generatively now. And once you have that wiring design, then I can take another step further and I can create all the materials that it might take to manufacture that wiring design or maintain that over the life of an aircraft. Again, a lot of tedious things. And we have customers saving thousands of hours of tedious kind of work of creating that documentation. And again, maybe it's not quite as sexy as Skynet, push a button and it falls out the other end, but it is sexy from if you're a CFO. And you're thinking about the time and money invested in what it takes to create these kind of aerospace products, because there's a whole lot of time still spent on doing all the paperwork. And really the time thinking the big thoughts that we all talked about as engineers. Engineers spend a good part of their time doing mundane tasks. And I think the key thing AI has allowed us to do in the past few years is really take on a lot of those mundane things. So that's the one hand. And there's some cooler things too that maybe we'll get to later in the podcast. But that's the heart of what I see AI doing for a lot of things in engineering right now.
Is AI the ultimate optimization tool for organizations?
The ultimate optimization tool. I don't know if it's the ultimate optimization tool, because AI is certainly a key tool, key aspect of what we're there. But when I think about tools and processes and digital transformation, I always think of it in terms of people, processes, and tools. And the thing about AI, which is the thing about any given tool, no matter how good it is, if a team chooses not to use it, if you don't have that vision from the leader, it's just another tool. Some of the power tools in my garage that probably should get used more than I do. They're great tools, but until I put them to use, I don't know that they're there. But certainly AI has the ability to do optimization in ways that we haven't thought of in the past. And with respect to optimization, one of the key aspects that I talk to people about AI as it's being applied in product design today, you think about AI going down this path and giving me the one best cool answer. And I think there are times where AI can do that. But in terms of optimization, I see AI's role as really eliminating a lot of the bad choices. I've got all these different options with variables and the way I can do this design. And what AI is doing today is it's saying, okay, you have 500 choices the way this design can go. Let AI start and say, there's 300. don't even mess with taking the time to simulate that and look at that. Look over here in this corner, because these are going to be some of your best choices, and really presenting some key best choices and focusing the time of human engineers so that they can be most efficient in applying the knowledge that they have.
How about from an aerodynamic perspective? There's been designs historically. Historical designs have not been very aerodynamic, that have not functioned very well. Is the AI helping to avoid those mistakes from an aerodynamic perspective when developing a new aircraft?
Again, I don't know if we call them mistakes. If you think about the design of commercial aircraft, from the 707 60 years ago to the modern 787s and A350s today, the tube and wing, right? They look the same. They've got fundamentally the same lift over drag coefficient. And there's all kinds of reasons that we've done that. When you look at, and part of those are, if you look at that design, or you look at any design as you go along in creating a large aerospace project, there comes a point, I like to say, the difference between an engineer and a scientist is scientists come up with theories, engineers have to ship them. Engineers are always working on a deadline. We've got to make money. And that deadline tends to cause us to suboptimize. And you bring it back to the realm of aerodynamics. There's a time frame that all these companies have to ship their product. And there's only so much work they can do in a certain amount of time with the tools we have in our hands today. What AI will let us do is do a lot more trades and a lot more studies a lot faster, so that maybe we don't have to suboptimize and we can do quite a bit more trades and understanding before we get to that critical design review and have to ship it. That's one thing things can do. AI also can expand our horizons and maybe let us think about and understand other kinds of things. We talked about the tube and wing aircraft. There are a number of companies today, like Nautilus, like Jet Zero, that are talking about blended wings. And AI certainly is going to give those companies the ability to optimize the aerodynamics of their aircraft in much faster ways. Now, I'm not going to go on record and say they're using AI. I don't have inside knowledge of those companies, but I suspect that if they aren't today, they will be soon. Using AI in terms of optimizing the CFD and the aerodynamics of those cool new shapes.
Let's go back in aerospace history. I'm going to give you a Howard Hughes curveball here with the Spruce Goose.
Okay.
If AI was around when the Spruce Goose was invented, how would it have changed?
If AI was around, if you think, let's talk about maybe why the Spruce Goose didn't work as well as we thought it would. I think it flew once, right, for a few hundred yards.
Yes.
Let's be real. The Spruce Goose didn't have enough thrust. It just didn't. It didn't have the thrust it needed to do the things it would do. So if AI, or maybe a more general term, if digital transformation and digital twins had been around, I think maybe Howard Hughes would have understood before he built that aircraft that his problem was, if you want to build something that big and that heavy, you need more thrust, you need better engines. And it might have caused him to change the engine design a bit, or it might have caused him to say, maybe it doesn't need to be quite so big, Howard, although I think the plane matched his ego a bit, I think, and that was probably a statement he was making. So maybe he didn't care because he built this giant statement of an aircraft. But I think it certainly could have done either one of those things. And back to this idea of that we talk about at Siemens all the time, I want to design it and fly it in the digital world before I create it in the real world. And certainly AI or digital transformation in general could have allowed Howard Hughes to have a better understanding of some of the limitations of that aircraft before he built it and flew it, and understood that it just didn't have enough thrust.
Is simulation digital twins another tool in the toolbox?
Absolutely. It's a tool in the toolbox. And again, if you think about it, and I don't mean to downplay AI. AI is so important, and we'll talk about maybe the future of AI in aerospace in a bit, but it is a tool. It's a way to make digital twins better. It's a way to make simulation better. And we've been talking about it in the industry about digital transformation and digital twins and simulations for a while. AI lets engineers set up those things quicker and lets them optimize them faster. Back to that idea of, it's not always about creating something brand new I didn't think about. Very often, it's about doing what I'm already doing much more efficiently. But yes, there's all kinds of tools in that digital transformation toolbox, and certainly simulation and digital twins are two of those.
How is a digital twin designed and developed? Does it start with a CAD drawing? Is there a proprietary Siemens software that you developed? How is it started and developed?
Let's think fundamentally maybe about what a digital twin is. And let's use an example maybe that's a little more relatable to somebody who's not an aerospace engineer. Let's think about a digital twin we all use every day. Everybody has a cell phone now, and everybody uses that cell phone to navigate. Okay, the Maps application on your cell phone is nothing more than a digital twin of the real world you're going to interact in. And you use that digital twin every time you travel to say, because we talk about doing things first in the digital world, if I'm going to travel someplace I've never been, I just took a trip to South Korea recently, where I'd never been before. So before I go there, I'm going to plan my route. I'm going to pull out my phone, and the sophistication of what our Maps apps let us do today, I can, in many cases in large cities, I can place myself there. I can visualize walking down the street and see what I'm going to see. That is a digital twin of the real world. Now, if you think about what Google had to do to prepare that, they had to collect data, they had to simulate it, they had to put it in a form that users could have access to. And that's very similar to what we do with digital twins in an aerospace application. So in a digital twin, we think about it as this 3D mechanical thing, and certainly a 3D mechanical model of an aircraft is a digital twin. But digital twins are so much more than that, just like the digital twin that Google created, because it certainly has 2D representation of the road, a 3D representation of where you're at, but it has all this other metadata of where I want to visit and what that restaurant is and what the hours of the restaurants are and when that aircraft flight is going to take off. In the same way, digital twins in aerospace have all that metadata associated with them. It's the 3D model. It may be the requirements that go with that as part of the digital twin. It may be all the material it takes to manufacture it in the manufacturing plan. But a digital twin is all those things, all the things it takes for me to think through the design of the device, as well as the manufacturing and build of the device, and to give me the ability to walk through all the processes that I'll need to test and understand it before I build it, as well as to understand how the manufacturing process is going to work. Because the more I can do digitally, the more I can invest. And the idea is I want to make all my mistakes in the digital world and have all my learning happen there, so that when I create it first in the real world, it's going to be optimized already. And the digital twin is all of those things. And it requires not just a mechanical CAD tool anymore, but it requires a whole product lifecycle management tool, configuration tools, and an integrated suite to put that together so that I have this fully realized digital twin that lets me understand and do all that learning before my physical device is built.
Can you pressure test an aircraft design? You can the rivets, the metals, the structure. Pressure test, and then can you also throw in weather elements as well into the digital simulation?
Absolutely. Again, things I've heard people say about models. All models are wrong and some are useful. That's a thing I've heard people say about models, and certainly I don't want to be criticizing digital twins coming from a company where we're talking about them. But the reality is a digital twin is an approximation of the real world. And we can certainly, and we do, have models and digital twins that approximate any aspect you can imagine in the design of an aircraft, from the way the rivets go together, to the pressure, to the weather. We simulate all those things. And there are some things that we simulate better than others, and they tend to be things that we can measure and understand in better ways. And also, when you look at the idea of a digital twin, we go back to the idea of economics. And there are some things that are very valuable and have a large return on investment in terms of a digital twin. And there are other things that, quite frankly, are so sophisticated and complicated, maybe they're not worth the investment. So the short answer, yes. Longer answer, it's all about the degree of sophistication. And in my career, I've seen digital twins that get down to the low-level physics and almost to the electron level, to the part level. And there's certainly digital twins like that. And I've seen digital twins at the macro level where we're looking at a first-order model to approximate an aircraft and everything in between. And digital twins are all of those things, and they all exist for a different purpose. And it's all about value at the end of the day and return on investment for what I'm going to get for creating and using that digital twin.
When did Siemens first start thinking about the digital transformation of industries? Because it seems that it's been a big capital-intensive decision to start moving that way.
I believe that's been the mission. I've only been at Siemens a couple of years. So I've been at Siemens a couple of years, and I've been a customer of Siemens for a decade before that. But I would say that has always been the mission of Siemens since the very beginning. Way back and Siemens is, like a lot of companies, a combination of many other companies. But there was one of the key parts of Siemens digital industry software started in a company called Unigraphics back several decades ago. And Unigraphics was a 3D mechanical CAD company that allowed you to create wireframe and other mechanical representations of an aircraft. And from the very beginning, I think Siemens has been at our core, about digital transformation, about helping companies design, develop, and deliver products better by doing things in the digital world before they do them in the physical world.
Where does generative AI fit into the toolbox?
Okay, so again, we'll talk about, let's go ahead and define when we say generative AI. When I think about generative AI, I'm thinking about the general definition would be something that uses a large language model in a prompt to produce an artifact. And generative AI is being used in many places right now in simple ways to do things like record. We have a thing we do with a partnership we do with Microsoft, I believe, called Copilot. And we use generative AI to use the large language model and generate artifacts around problems that we find in the factory floor. Again, sounds like a pretty simple task, but if you think about in the development of an aircraft, how many times that happens. And sometimes problems don't get properly reported simply because of the overhead that it takes to go through that process. And generative AI can do something as simple as that, all the way up to, as I was talking about earlier in the podcast, generating full electrical system designs. And certainly we have tools today that can generate the electrical design for a subsystem or a major part of an aircraft all at once. And it's being used like that today. I see generative AI as such a great, I guess I feel like we're just at the very beginning. We think about the arc of where AI and specifically generative AI will go. If it's a 12-hour clock, we're like in the first 5 seconds. That's where we're at of that 12-hour life cycle of where generative AI will go. And there's so much promise and so much opportunity. Again, it comes back to more sophisticated models and more sophisticated hardware to run those models on.
There's promise and opportunity. What impact will generative AI have on product development? Will we see really new, exciting products being generated from some prompts?
So I've said in the past, and I'll say it again, if we look at the year now and look forward to the year 2033, I think that AI in general and generative AI specifically will completely and fundamentally change how aircraft products are developed. And I'll go even one step further. I think that by then, as I've said, by 2033, there'll be two kinds of companies, product development. There'll be companies that have fully embraced AI, and there'll be companies that are out of business. And that's a bold statement. And I started saying that last fall as I was investigating AI. And I think the only modification I would make to that now, the prediction I made last fall, is that I don't think it'll take 10 years. I think it's going to happen faster than that. I don't know, maybe it's 4 or 5, I'm not sure. But what we've seen with the rise of NVIDIA, if you think about their market cap, and we've all heard about the $2 trillion that a market cap that NVIDIA developed grew over 17 months, it's going everywhere. And it's going to be a part of everything. It's going to be a ubiquitous part of our everyday lives. And certainly that's going to be true in our everyday lives. It's going to be true in product development too. And it's going to create, I think, an environment, incredible opportunities. And you ask how it would change. That's how it'll change at a macro level. At an engineer's day-to-day level, I think it's going to make the whole process of engineering that we do a much better environment to work in. Again, because a lot of the things that are the pesky things that we didn't want to do, we don't have to do anymore. We can let the AIs do that. And we can focus on the bigger, broader, more important things. So I think there's all kinds of great opportunity for AI. I think AI will make the world of engineering a much better place to work in.
I agree with that. What are the regulatory hurdles or issues that could come down as AI transforms industries?
From a regulatory issue, I think we go into a couple ideas around trust and maybe several ideas around trust. I think certainly you look at AI and we see AI many times like other tools in the past as a black box. And I think a lot of the regulatory agencies will say, we don't understand that, so how do we trust it? And I think that's incumbent upon all of us in the industry to educate ourselves, educate our customers and the regulators about what's really happening in AI. It's just another software algorithm. It's more sophisticated than software algorithms than we have today, and it can learn. So that's an aspect of trust. Also, there's an aspect of trust around intellectual property. And I think in terms of, if we think about laws, because when I think about regulatory agencies, I think about laws and how we regulate how things are working. I think there's going to need to be some changes probably in the future about how IP is protected. Because if we think about how IP lives inside of companies today, it's in pieces, it's in written documentation, it's in the minds of our employees. One of the things that these large, sophisticated AI models are going to do, they're going to allow us to encapsulate intellectual property in ways we've never even dreamed of in the past. And that's great in terms of retaining knowledge that companies have and reproducing that and training new employees. That's the good side. The bad side is, to some extent, I've got the family jewels of what I know in intellectual property for a company is all encapsulated in this model. And if I lose that, if it gets used improperly, wow, that's a big risk to my company, as well as we've seen with the public chatbots like ChatGPT and this whole idea of infringing on someone else's intellectual property. We've all seen the lawsuits of companies like New York Times, where they've said, you can't let ChatGPT do that. You stole my intellectual property from the article I wrote. And where's the line? It's pretty gray as to, can I make something like what you did? Do you own it or do I own it? And those are all regulatory things I think we're going to have to deal with. We're dealing with it in the entertainment industry now. We're going to be dealing with it in the product development industry in the future too, as our use of AI becomes more sophisticated, and specifically as we train larger and larger models about our intellectual property. Most employees have to sign an NDA. We all did when we joined an engineering company. And it's one thing to point to a document or something when I walk away, but how do I put an NDA on what's in my mind? And where do I draw that line about what's mine and what's yours in terms of ideas once I leave a company? And I think AI is going to create some interesting legal ideas, things we have to deal with in the future with respect to training models and who really owns that knowledge.
It's going to be full of landmines. I think a lot about it from a consumer standpoint. There's a company, I've spent hundreds of hours researching it and speaking to bankers and lawyers, and I can't get an answer on what I'm going to ask you, is that they're gathering all this public data and they're modeling it, and they're not disclosing it to the public. To me, that's a security risk. It's an SEC security risk that's not clearly disclosed. Where are we going to get to the point where all this data is being trained? When does the consumer say, wait a second, I was a part of this. I was a part of that. Right now it's in the company level, but eventually it's going to get to the consumer level because, let's face it, your customers operate public aircrafts. They're going to get some data off of there. When do we get into that hurdle and cross that?
So let me get this straight. You've asked hundreds of other people and lawyers and smart people, and they couldn't answer. Now you're asking me. Is that what you're saying?
You're a very sophisticated engineer, so yes.
I think it's a good question. I don't know if I have a direct answer either. I think I'll say what a lot of lawyers would tell me. I think it depends. It depends on, and we're not going to solve it. It's not a problem we're going to solve all at once. It's a problem we're going to solve in pieces, I think. And like I talk about developing AI in general, we're not going to all of a sudden wake up and have Skynet invented tomorrow. We're going to, or let's say a self-aware AI invented tomorrow. And I don't know that any of us want that today. But in terms of the ability to use sophisticated generative algorithms to create products, that doesn't happen all at once. It happens in pieces. And I think with respect to understanding who owns what in a model is an aspect that we'll have to deal with a piece at a time. And it reminds me of a story. I was at CES last January with respect to AI. And I went to all kinds of meetings on it. And one of the most interesting topics I was in had to do with one of the executives from SAG, from the Screen Actors Guild. They just solved their strike. And he was describing some of the issues like you're talking about with respect to AI. He says, let's play suppose. I'm creating a new Star Wars movie. and I decide I need a scene with the older Obi-Wan Kenobi in it. Obviously, Alec Guinness is now deceased. Okay, but we have AIs that could easily create a scene with Alec Guinness in it. So if we do that, who owns that? Does the person who created the AI algorithm own it? Is it owned by the estate of Alec Guinness? Is it the producer of the movie? We don't know. And that's just one of the myriad of issues I think you're talking about with respect to the sophisticated use of AI to pull all these different pieces of data that exist on their own, put them together and create new content. And it's certainly a brave new world. And I don't think that we've nearly ended up solving all those programs yet, all those issues yet. I will say that I hope for the good of society, we find a positive way to restrict those issues. Because take the example of Alec Guinness, I'd love to see another Star Wars movie with Alec Guinness in it. And I'd hate to think that legal battle would prevent that really cool piece of movie history from existing simply because we couldn't solve the legal issues. And I'll say the same thing about engineering. There's all these great engineering possibilities that lay ahead. I hope we can solve the intellectual property issues to get there.
Does it become the Robin Williams clause? Robin Williams, before his untimely passing, has a clause in Disney's Aladdin that you cannot use any of the outtakes, any of the voice, any of that was written into his contract when he was alive. Perhaps that becomes the model going forward. But you look at Alec Guinness and you look at Bridge on the River Kwai. Oh, I said, this is a great movie, Academy Award winning. Well, let's remake it with Alec Guinness. You're right. You open up all those things. That perhaps you get the Robin Williams clause written into contracts. We don't know, but it's going to be interesting to watch how AI transforms these industries, create value. Tyler Perry put his studio on hold because of AI. There's videos. Mark Andreessen put one out on X where he had a podcast interview for 30 minutes. He goes, it wasn't me. It was all generated. And he was just showing you, and you would never believe it, the impact this is going to have. What are the cost implications that AI is having? Is it increasing cost? Obviously, you have the data center cost, but from an operational standpoint, my CFO hat on, I'm going to lower my operational costs here. So what are the cost implications?
You mentioned a few of them. Certainly one of the cost implications and just the technological implications. If I'm a company and I'm interested in using these very sophisticated models, at least today anyway, a lot of these large models can't run on my PC. They've got to run on a data center somewhere. If I'm thinking about the future use of these models, I've got to factor in that cost. And certainly, I guess at the bottom line to me is there will be some investment. But I see the payoff being an order of magnitude or orders of magnitudes greater than the investment. And that's certainly one of the cost aspects. And maybe, I don't know if you wanted to go here, but if we talk about financial aspects of AI, it's going to change economies. If you think about, let's talk about an economy and an industry that was transformed by a technology change. Let's look at the film camera industry. And you think back 30 years ago about the invention of the digital camera. I can think back in my lifetime, I can remember I had a film camera, going into a camera store, getting camera developed. Okay, when's the last time anybody on this podcast walked into a camera store with analog film and had it developed? Those used to be everywhere. Those don't exist anymore. And so that industry was transformed by digital cameras, but then it was transformed again because all these companies had all these digital cameras, and then somebody put them inside a cell phone. And the whole need, so it was transformed twice. In terms of cost, in terms of financially transforming an industry, AI is going to do that time and time again. And there are in ways that I think we've only begun to scratch the surface and understanding of. But there's all kinds of industries that exist today that in 5 or 10 years aren't going to exist in any of the ways they do today because AI is going to make them obsolete. The digital camera did for Kodak film.
And Kodak had the patents on the original.
They did.
If
you go there, yeah, a whole sad story about what Kodak didn't do.
And then the other thing that nobody talks about with Kodak that they made a mistake is they were out innovated by Fujifilm on the chemicals to process the film. Fuji made better chemicals, cheaper, and that was another thing that they lost. And we don't have 1 hour photo anymore.
Right.
Those were on every block.
That's right.
But it's changing. AI is transforming everything. How is Siemens layering AI on top of the company's 5-step digital transformation framework?
So let's talk. Maybe some of our listeners aren't familiar with the 5-step framework. So I'll quickly go through that. We have a framework for what we call digital transformation maturity. There's 5 steps. It allows companies to understand where they are today and where they need to go. And the first step is configuration. It's just getting your data in a data system, configuring it, turning it to digital, and being able to configuration manage it. That's the first step. The second step is connection, connecting all that data together so I can start doing analysis with that data. The third step is automation. I talked a bit about automating the mundane. It's automating things that engineers would rather not do that leads to automating the complex, which is automating things we thought only engineers could do, only humans could do. And that leads to generative design, generative AI kinds of applications, as well as optimization, where if I can generate a design once in the digital twin, I can simulate it, put the digital twin through simulation, feed that back and optimize it several hundred times. So that's the 5 steps. Now, if I look at AI, AI is being used in all 5 of those steps. But really, the key aspects of AI and the application at Siemens really comes in the third step, automation. As we talked about automating the mundane, things that people don't want to do, that's the gateway drug, I think, into this whole issue of both digital transformation maturity and taking your company further along in that path, but also can be the gateway drug for just AI in general, in convincing the CFOs that there's quick wins and I can get a quick payback on my investment, as well as convincing engineers that we're not going to take their jobs away, that we're going to make the environment they work in better. That's automating the mundane. Once you take that step, then you can start really getting into the key return on investments where you talk about doing generative designs. And if I can, again, generate it once through AI and digital transformation in a computer, then I can feed it into an optimization algorithm and I can design that thing 500 times, 5,000 times, fly it, test it, drive it, understand it digitally, find the mistakes. I can do that 5,000 times before I ever build the first model. And to me, that's the real payoff for digital transformation in our 5 steps. And that's what AI is going to enable, just the faster adoption of that, the better applications of allowing companies to do that, go through that process quicker. That's really where we're layering AI. And again, like you said, we're not selling AI as a product in and of itself. Again, a key thing, we're using AI to make all the products we already sell better. That's our strategy. That's where we think we fit in the AI world.
It's a smart strategy. You're unlocking efficiencies. As you look to unlock efficiencies for your customers, how should companies start thinking about implementing AI into their workflows today?
I think some of that's probably proprietary as to how we do it in our workflows. But internally, we are certainly using large language models and generative AI because, as you can imagine, if we just look at DISW, we're about 25,000 people in a much, much larger corporation. And when you talk about companies that large, you're talking about large amounts of data sets and just finding information about who our customers are, what our customers' needs are, where our product roadmaps are going, just finding and disseminating that information sometimes can occupy an army of people just to move data. So we're certainly, like I think a lot of other companies, employing AI within our company to help find and aggregate and use information better, as well as using AI, like most software companies are, to better develop our products. So I think at a high level, that's what I can talk about. I think the details is probably not something I want to get into on a public podcast, but we're eating our own dog food. We're using AI in many ways, just like we're recommending our customers do too, because we see the power of how it can make all the things we do far more efficient.
Are we now at the point where we could say that AI inside, based off of the Intel from back in the Intel inside, are we now the point AI inside our products? Are we there now?
I really can't imagine. If you think about most sophisticated products that are designed today, I think just about anybody could say that, because you think about AI affects the whole world around us, right? It's in that Google map I talked about before. We use AI every time we go to Amazon to get a recommendation. There's AI algorithms behind there predicting what I'm going to want. If you want to get scared, I do this sometimes. I go to a computer I use often, and I think about how much Google knows about me. And I'll think of I guess I'm a geek this way, but I'll think about a 6 or 7 sentence phrase I want to do for search, and I'll type one word, and I'll count how many letters it takes for Google to predict my entire sentence. And it's scary how much Google knows about me. And I guess I say that to say that I think AI is already inside to an extent most of the products we use every day. So I think we're already there, and we're just going to go faster and faster in terms of the AI adoption and all the benefits we're going to see AI in the product design space.
It's going to be beautiful, Todd. This has been a wonderful conversation. As we look to wrap up for today, what would you like our listeners to take away with them?
I always talk about, with respect to AI, if it's something that's new to you, don't look at it as some futuristic thing that's going to be there for you to use someday. Act right now. There are so many ways that AI can make your product development process and just your employees' life better. So many ways that you can use AI applications right now today. So I'd say act now, don't wait. It's not a far off thing. If you wait till 3 years from now to figure out AI and what your strategy is going to be, your customers will beat you to that. And if you think about my prediction about two kinds of companies, ones that embrace AI and ones that are out of business, you don't want to be on the back end of that discussion. And that's where a lot of companies will be if they decide to wait and see. Don't take a wait and see attitude. The water's great, jump on in. There's all kinds of great ways to apply AI to make your company better.
Act now, embrace AI. Today is tomorrow, tomorrow is today. The future is Siemens. Todd, thank you so much for coming on SAE Tomorrow Today.
It's been a pleasure. Thank you for having me.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.